Okay, in this video, we're going to be talking about measures of central tendency and variance. And what we're doing here is we've got list of numbers, we've got data that we've collected, and we want to know um, about where this data is located at and how spread out is the data. And that's all measures of central tendency and variance is. And we're going to start off by actually defining measures of central tendency. And a measure of central tendency is a value that describes the center or the middle of data. And there's actually three types of measures of central tendency. There's a mean, a median, and a mode. And you've probably heard of these before. Now, I do want to start off by saying this. Mean and median are used when we're talking about a group of numbers most of the time. We're talking about numerical data. Maybe we're talking about the height of something or weights or income, average income. And we have special situations where we use each. But mode is used when we're talking about categorical things, such as we want to know maybe somebody's favorite color, and we take all this data and we want to see, okay, which color occurs most often. So that's the difference between the two or between the three. So let's go ahead and define each. And we'll start with a mean. And notice the symbol that we use here. This symbol is actually called mu. And all the mean is simply the average. And we've done that before to where we add all the values up and actually divide by how many there are. Next up, the median. The median is simply the middle value, and we do have to put the numbers in order before we find the median. And something else that's very important, if there's two numbers in the middle, we actually average those two values again. Now, before we go into mode, let's talk about when is an appropriate time to use mean and when is appropriate time to use median. If there's ever outliers, and what I mean by outliers, let's say that you have a list of numbers 2, 3, 4. And if I were to ask you to find the mean of those, if you were to add those up and divide by 3, you'd actually get 9 divided by 3, which is 3. So that would be a good mean value. However, if you ever have an outlier, let's say that you have 2, 3, 4, and then you have the number 100. This number 100 is going to very much skew my middle, because the middle here should be, if I'm just talking about 2, 3, and 4, again, the middle will be somewhere around 3. But as soon as you throw in this huge number, now all of a sudden your mean is going to be around 30 or 40, which is not very indicative. It doesn't very much describe the middle of this data. So if you ever have extreme values, the median is going to be a better choice, because the median, again, you're going to take the middle two numbers. So the median here would be about 3.5, which very well describes the data, even though you have this outlier. So mean is very useful when you don't have extreme values, median when you do have those extreme values. So now let's move on to mode. In a group of number, the mode is simply the number that's most repeated, the most repeated value, the number that occurs the most. So if you have 3 2s and 4 3s, well, if you have 4 3s, it occurred more than the 2s did. Or again, we go back to the example of favorite colors. So now let's work some problem. It said on number 1, it says find the mean, median, and mode for each data set. Again, in order to find the mean, we're simply going to add the numbers up and divide by how many there are. So with this set of numbers, when I add up all the values, I get a total of 471. Then I simply have to divide by how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 values. And when I do 471 divided by 9, I get a value of around 52.3 repeating. Next up, to find median. Again, we're going to have to put these numbers in order, so let me go ahead and do that. And now that we have the numbers in order, we simply have to find the middle number. Since there's 9 numbers, that means there's going to be 4 below, 4 above, and the middle number will be the 5th number. So our median there would be 53. Now, something else that's nice is when you have these in order, you can look for all your repeated numbers, and that's going to help you with the mode. So you've got 51 repeated, you've got 58 repeated, and since both of those occur twice, that means you actually have 2 different modes. You have 51 as a mode and 58 as a mode. The second one, again, to find the mean, we're simply adding up all the numbers, and we're going to divide by how many there are. The sum of these numbers, when I add them up, I get a total value of 228, and there are 12 different numbers, so we're simply going to do 228 divided by 12, and that's going to give us our value of our mean, which is 19. Next up, again, to find our median, we're going to have to put these numbers in order. And once we have these numbers in order, now we're simply looking for the middle number. Now, here's the only problem. There's 12 numbers, and that means that there's no true middle number because it's even. There is actually 6 numbers below and 6 numbers above. So if we're looking for the middle number, the middle of these values is right here. So both of these numbers are in the middle, 19 and 21. Now, to find the median in this case, you can have two different medians. So what we're going to simply do is add those two values together and divide by 2. So we're actually kind of finding the mean in order to find the median, the mean of those two numbers. So we're adding them together. We get 40 divided by 2, so that gives us a mean of 20. Now, the next thing, again, in order to find the mode, we're simply looking for repeat numbers. There's 2 15s. However, there are 3 24s. So since you have more 24s, that means that will be the mode. Okay, next up, we're going to be talking about measures of variation. And by definition, here's what we mean by a measure of variation. It's simply a value that describes how spread out a set of data is. So we know now mean, median, mode tells us that middle value, but now compared to that middle value, how spread out is all of our numbers clumped together right there around the middle values, or are they very widely spread? It's a measure of dispersion. It shows how dispersed those numbers are. Again, how spread out they are. And the first measure of variation we're going to talk about is the mean absolute deviation. You can call it the MAD deviation. And by definition, the mean absolute deviation is the average distance that each value is to the mean. Now, when we're talking about distance, I want to go over here and look at this formula. The stuff inside the absolute value bars. When you're talking about distance, let's say that you've got two numbers, 5 and 2. And you want to know the distance between those two numbers. Well, there's two different ways you can do that. If you subtract 5 minus 2, you get the distance of 3, but there's a problem is what if I subtract it in the other order? I get negative 3. Now, distance is never negative, so that's the reason in our formula you notice the absolute value bars. And what that absolute value bar does is what we're going to do is we're going to take each value, we're going to take each number in our list, and we're going to subtract it from that mu, from the mean. And we put the absolute value bars around it just in case if the number is smaller than the mean, when you take the absolute value, it still gives you a distance. So what this says, we're going to sum them up. We're going to add them. That's what the summation symbol is. We're going to start with the first value in our list, and we're going to go to the nth value in our list. And what we mean by n is, like in this first example, there's 6 values. So we're going to sum all the values from 1 to 6. We're going to find their distance from the mean, and we're simply going to divide by how many there are. We're going to average those distances. So let's start out in this first example. The first thing you have to do is we actually have to find that mean. So let's do that first. Again, we're going to add them together and divide by the value 6 because there's 6 values. And when I add them up, I do get a value of 479. And since there are 6 values, I'm going to divide that by 6, and that gives me a mean of 79, and that's approximate 79.83. So again, this mean absolute deviation, again, now all we have to do is take each of these, and we're going to find the distance, or how far they are from that 79.83. And the way we're going to find that is we're going to subtract the values. And if it's a negative value, we're going to take the absolute value of it. So now what I'm going to do is one at a time, I'm going to take and subtract them. And if it's a negative, simply make it positive. And there's my list of distances. So again, what we're looking for is, on average, how far is each of these numbers from the mean? And there's how far they are from the mean. So in order to find the average of that list of numbers, we're simply going to take and find pretty much the mean of those numbers. We're going to add them together. That's those distances, and simply divide by 6 since there's 6 of them. And when we do that, we get a value of 51.34. That's the total of all the distances, and we're simply going to divide that by 6, and we get 8.56. So again, what that actually is telling you is on average, our numbers are around 8.5 from the mean. And you can see that very easily with the very first number, 79 to 0.83 to 85. Well, that's around 5 from the mean. The second one's close to 6 from the mean. The third one is around 8.17 from the mean. So again, these big ones skewed it a little bit, but on average, that's how far our numbers are from the mean. So let's do that one more time. So number 4 again to find um, the average distance of these from the mean is first off we've got to find the mean, and I went ahead and did that for you on this first one. The mean is 18. We add them all up and divide by how many there are, and then just one at a time we ask ourselves how far are these numbers from the mean. So the first one has a value of 4 from the mean. The second one has a value of 0 from the mean. It actually is the mean. The third one has a value of 2 from the mean. And we just continue on with the rest of the list. And there's all of our distances. And again, what we're actually looking for is the average of those distances. So since we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, that means we're going to have 10 distances. So we're going to add all these up and divide by 10 since there are 10 of them. And we're going to get 26 divided by 10, which will have a value of about 2.6. So that's our average distance from the mean. Okay, now we're going to talk about two other types of measurements of variation. And the first one's called variance. And notice how the absolute value, again, that made our distances positive. Now, this will also do the exact same thing. Is what we're going to do is we're actually going to do the exact same subtraction. We're going to take each value in our list, subtract it from our average, and then instead of absolute value, we're going to find the square of it, and then divide that by the number in our list. And again, that's called variance. So variance is the average squared distance of each value to the mean is what we can say. Now, I want you to notice that, again, we see the symbol for variance is this symbol squared. And this symbol is actually the lowercase sigma, but again, we have sigma squared, and that's the measurement of variance. Now, I want you to notice the next one, standard deviation, is actually just sigma. So notice what we've done. We've just took the square root of all of that variance. So the square root of variance is the standard deviation. So we're going to define standard deviation as simply the square root of the variance. And this is hands down the most useful measurement of dispersion. So what do these numbers mean? So let's talk about what does it mean to have a lower standard deviation versus a higher standard deviation. And again, remember that standard deviation is telling us how spread out our data is. So if we have a low standard of deviation, that indicates that our values are closer together, because on average, the numbers are fairly close if you have a low standard deviation. So opposite of that, a higher standard deviation, that would indicate that the values are more spread out. So again, that's just simply the average of how far the values are from your mean. So on the next example, it says find the variance and the standard deviation for each data set. So we've got 5 values here. And again, first step is we're going to have to find our mean. And the mean of this data set is 92. Now, what I'm going to do just to show you on this first one is we're going to do a chart to show you how to calculate this. So let's go ahead and make us out a chart. And here's what I'm going to do with the chart. First off, I'm going to take all my elements, all my data sets, all my numbers in my data set, excuse me. And that's what I'm going to have in my first column. Then I'm going to subtract off the mean, like the formula says. It says take each data set to find the variance, take each take each number in the data set, subtract the mean, and then finally it says to square it. So let's go ahead and list all the numbers in our data set. And there they are. And again, the second column is we've got to take each number, and step number 1, we've got to subtract them from the mean. And there's the values that I get when I subtract them. And then finally, we take each value and we square it. And notice that squaring it takes care of those negatives. And really, we don't even have to worry about the negatives, but that's what we get. That's our value squared. So the formula says that we're going to take all of our values squared. We're going to sum them up and simply divide by how many there are. So we're pretty much just going to find the average of these numbers. So we add them up, divide by 5, and we get a variance of 29.2. But again, that's not the useful one. The useful one is the standard deviation. If the variance, which notice the symbol, if the variance is sigma squared, lowercase sigma, if variance is sigma squared, in order to find standard deviation, we simply have to find the square root of that. So the square root of 29.2 gives us a variance of 5.40. And again, that shows you how spread out that data is. And I'm going to go through those steps again. Take each element in your set, subtract it from the mean, square it, and then just average all those values together. And that'll give you variance. And then to find standard deviation, simply take the square of that variance.